All right, so a few of you are having trouble with this loop here where it uses the t-test to test whether the mean of the data in different columns are actually different or not. And I'm not going to get into the t-test itself. Hopefully you'll get into this much more in design of experiments. Okay, or you can take a look at some of these Khan Academy videos that are very good, looking at the different types of t-tests. All right, but let's go ahead and pull this apart a little bit, especially when you get errors, and that was what's been going on with y'all. You have to pull this apart and look at the different pieces to figure out where your error is. Okay, you won't be able to figure it out by just correcting things and trying this whole loop. So let me first just show you what my data looks like. So here's my data, okay, that I'm dealing with. So when you're checking this, the first thing you do is check to make sure that the format of what you're using is the same as my format. So you should simply have some columns here with some numerical data in it. Okay, so that's the first check. So the second check would be to just take a look at this t-test independent of this loop. Okay. Now, what I want to do is just remind you that when you're finding or trying to pull out a value, say, out of this table, right, one of the ways that we can do that is through this location operation. And this location operation is row column. Okay, that's what we need to put in. So if I was going to grab the row indice, in this case you can see them labeled here, 1, 2, 3. So let's say we grab 3, and then I was to grab a heading. So let's grab Matt Minor. Then I would grab out in this case this value 2. Right? So I'm looking at row 3, column Matt Minor, and I get this value 2. Okay, what I'd like to do is I want to grab all of the values in this column. I still have to give it something here for the row, so what I can do is, well, let me just show you one other thing. Let's say I wanted to grab rows 2 through 4. So I could do that, right? It'll take 2, 3, 4. So I'm just using the colon, and that's what it pulls out, 3, 2, 4. So the shortcut, if I want everything, because I don't want to have to, this isn't all my data, right? I look at just the head. I don't want to have to go through and find out how many data points I have and then put this in manually. The shortcut is just to use the colon. The colon says to grab everything. So if I don't specify, then it's going to grab all the rows. And my column here is Matt Minor. Okay, so we can do that. You can also do that on the column. For example, if you wanted to get Matt Minor through anisotropy. Okay, it'll grab all of the rows, that's the colon, and it'll grab the columns from Matt Minor to anisotropy. Okay, so the same idea works. All right, so that's just a little review of how we can slice pandas tables. All right, now the other way that we can do this is with the location in which we're using the labels. Okay. The other way we can do it, if our labels aren't convenient, or it's easier to go in a loop and go through this with just telling it which column number to use, then we would use the I location or integer location. Okay, same order of row matrices, except now I'm going to have to tell it what column number I'm interested in. Remember, in pandas, the first column is indexed as 0, and then 1, 2, 3, 4, 5, 6, 7. Okay, so 0 here would then grab me the Matt Minor column, right? 3, 3, 2, 4, 4. You can see that. Okay, so 7 would be the last one here in ours. This is the regression, 2, 4, 2, 1, 4. You can see that. Okay, now if I want it to grab, let's say, go back to 0 for the Matt Minor column, let's say I wanted to grab this value here. Okay. When I did location, I used the indice, which is just like a label, just like the columns were, 3. Okay. But now I'm again using the integer, and rows are also started counting with row 0. So this is really 0, 1, 2. So I would have to put in 2, 0, and that gets me this value here. Okay, so you just have to be careful of the two methods of slicing. So here I'm testing this t-test relation on my data. I'm using the location, so that means I'm going to be using the names, and I'm going to grab all of Matt Minor data, and then I'm going to compare that to all of the data in the regression column. Okay, and this is the format. This particular statistics function t-test will output 2 values. It returns 2 values. And so I can use this shortcut to tell it, okay, the 2 values you return, call the first one T and the second one P. And that's the order in which they're given. So I run that, and that works. Okay, so that's great. All right, so let's go down then and see what we've got down here. So this is where people got a little bit messed up. I think the 2 main errors I saw was, notice in here I switched to this integer location, okay, and I fixed the data set that I'm going to look at compared to everything else is 0. That, remember, is the Matt Minor column, and I want to compare that to all of the other columns, right? So columns 1 through 7 in this case, right? So 0 compared to all the rest of these. All right, so this is what I want to look at. And in some of your cases, this was not working for you. We could pull this out and manually put in I, just to make sure that everything is okay. So let's say I equals 1. Okay, I forgot my print statements. It won't show me anything unless I actually print them. So, but I didn't get any errors, so that's good. All right, so that worked. And I could test this, right? So my lowest bound was, say, is I equals 0, comparing it to itself. So I just get this output basically saying not a number. And then if I go all the way up to 7, okay, that should be the last column, regression. If I try 8, I get an error. Okay, so I know that I can only go from 1 or 0 to 7, really 1 to 7, but all right, so that's the range. And so that's where a lot of you had some errors to start off. Some of you don't have the I here, and so you're using the location, but you're not using the names of the columns, but you're using numbers. Okay, so this, if we're going to use numbers in our loop, then we're going to need to do this with the I location. All right, so now the I in the loop is going to need to go from 0 to 7. Okay, so I've got here this function numpy a range. And numpy a range, if we pull that out, right, and hopefully you're doing this when you get things like this, that you're not just filling it in your data and running it and being happy that it works. You should pull things out of here and figure out what each thing is doing. That's the part I want you to do so you can learn what's going on here, right? It doesn't really do you any good if you just run it. So let's see what this does. Okay, so I can't run it like this. I need to put a number in here. That's what I'm passing it. And so if I put in a number, say 5, one of the things you can see with this function is that it gives me 5 values back, but it starts at 0. Okay, so when I do 5, it's going to go from 0 to 4. All right, and that's fine. So what am I going to put in? I need to know the number of columns, right? We have 8. So I need to feed this the number of columns. Well, how do I get those? Remember, length is a nice command that calculates the length of some set. If I take the length of data, right, I'm going to get the number of rows by default. It calculates the number of rows. All right. but I want the number of columns. So one thing I could do is maybe grab all of the column names. So data.columns. You can see here that gives me a listing of the column names. So then I could just go ahead and find the length of all the column names, and I get 8. Okay. So that's what I've got going on here. So I'm going to go ahead and do the numpy a range on the number of columns that I'm getting from finding the length of a list of the column names. Okay, so some of you just did length data. That's finding the number of rows, not the total number of columns. So that's where you had a little trouble here. Okay, so I'm going to go ahead and do that. So length data columns. So this is numpy.arange. Just show you what's actually going in. There it is, 0 to 7. So, and I'll leave it that way. I don't really need to test 0 since that's the same column that I'm comparing everything to, but it's fine. We'll just kind of ignore that data. So that is my I function, and then it loops through here. So next thing I could do if I am debugging is just make sure I understand what the loop is doing. So here I have those 2 steps, and I know my number of columns we said comes out to be 8. And so when I do this A range, it gives me an array from 0 to 7, 8 values. And so that's all I need for a loop. I could just do something like this, and just to confirm that the loop works. So everything I put in here indented is going to get run one at a time as I goes from 0 to 7, and there it is. Okay, so my loop seems to function. It makes sense to me. And so the next thing I got to do here is I'm going to run this t-test. I fixed the first one as just the mat minor, which I'm comparing everything to. I'm using I location so that I can just use number indices. And now I is going to go from 0 to 7, so that'll look at each row. And then when I go ahead and do that, remember this returns a t and a p value. I'm going to go ahead and look at the p value. And if that's less than 0.05, which is a typical condition, statistically saying that with 95% confidence, essentially that my 2 columns have a significantly different mean value. Okay, and again, you can take a look at the videos below to see where this comes from, but this is kind of a standard number. So if p is less than 0.05, then that's going to mean that my data columns have a different mean value. Okay, so I'm going to then say print. This is a little review here for our print statements. You might not remember from 2114, or maybe you took Mathematica, so I just want to go over this real quick too. So this print statement, it's called an F format, F statement, F string, sorry. And so what I'm going to do is I'm going to put an F out here, and then my string is given in these quotes. And you can use single or double, but there's the ending quote, the beginning one. And I can just put whatever I wish to print out in here in terms of text. So there's my text. Okay, got all my text in here. And to make this nice and meaningful, what I'd like to do is pull what data column I'm looking at. So if p is less than 0.5, then I'm going to say my column, sorry, data columns, that's the names. So that's my 0, 1, so that's going to say mat minor all the time, in my case, is statistically different than the mean of, and then whatever I step I'm on. So I'm going to pull out the I name of my column list. Okay. So that's what it's going to do in that particular case. All right, and then the way that I feed values into a string statement like this is just using the curly braces. That's all. So anytime it sees the curly braces, as long as I have this F out front, it's going to look for this variable and substitute it in for me. So that's great. If p is not less than 0.05, so that's my else statement. Notice that it has the same alignment as the if. And then notice here with the if, I had to indent. This is the way we always do statements in Python. You always have an indent when you're inside of some kind of an if or a for. So else, I'm going to print that they're not statistically different. All right. And then, once I do that, I'm going to then print out what the values are for t and p from my Ttest function. So again, this is an if statement. I'm going to say the t value is, and I'm going to send in t, curly braces, and my p value is p, my variable p, right from here, with curly braces. Now the t and p here are defined by this statement up here. Okay, so this thing returns two numbers. It doesn't return a name for them. So I could call this t and this p value anything I want. Okay, with the Ttest, it makes sense to call them t and p, but I could have called these anything. I could call this p value, for example, and I just have to put p value here, same variables. All right, but I added a little something extra in here. Not only did I put the variable, but I used this colon, and this tells it to format the variable according to what I have next. And then the 0.3f says to format it with 3 decimal places as a floating point number. So that's what I've got going on. And so you notice that all my outputs have 3 decimal places, okay, and they're floating point numbers. Otherwise, it gets a little bit messy. Let me run this, make sure I didn't mess anything up. So if I don't have this in here, for example, that's fine. But then I'm going to get, you know, t is equal to all of this. And that's just ugly. So that's why we can do this. Maybe I want to do 0.2f, for example. Okay, so 2 decimal places. And that's the formatting command. Okay. This last print statement I did because I just want a space between all of these. If I don't have the space, then they all kind of run together. That's all. So just for looks.